Hello students, today we are going to move on to three-dimensional figures. When we talk about three-dimensional figures, we will talk about three groups. So the first group is called prism, second one pyramids, and the third one spheres. Prisms and pyramids, all their faces should be flat, so they do not have curved surface. And for prism, you have something which is called base. However, for prism, it might be more suitable to be called cross-section. What does that mean? So in a prism, there should be two congruent or exactly the same shape and size two-dimensional figures that are facing each other and they are parallel to each other. And those we will call the cross-section. So for instance, in this case, because it's a rectangular prism or a cuboid, then it doesn't really matter. You have three pairs of those parallel shape. So I will show it here. For instance, you have this at the bottom and this one at the top. We call that the cross section. So if you imagine you cut this prism along the shape that are facing each other parallel, then you get exactly the same shape all the time. So this is what I meant. If you cut it along this shape all the time, then you get exactly the same figure with the same size. Now here, with this triangular prism, which one should we call the cross section? Remember, you can identify it by the two shapes that are facing each other parallel. This triangular shape should be the cross section, because if you imagine you cut this figure into pieces along this figure or shape, then you'll get exactly the same triangle all the time. Okay, similarly here as well, the cross section should be the one in the shape of a trapezoid. Okay, and now we have something which is not really a prism because it has a curved surface, not all flat. So this one is called a cylinder. Although it's not a prism, but it's very, very similar, because if you think about it, the cross section should be the circle. If you cut it along the circle all the time, then you get exactly the same circle with the same size. So it's very, very similar. Okay. And the last figure is a composite one because it is made out of a rectangular prism or cuboid and then half of a cylinder. And if you actually think about this composite shape as its cross-section, then it's a very similar feature as a prism, because you will get exactly the same shape every time if you cut it along this figure. Okay? All right, for a pyramid, then you have something which is called the base with a certain shape, and all the other faces are triangles. And all the other triangles then goes to one point, which is called the apex. Okay, so that's the property of a pyramid. So here you have a rectangular pyramid. Here you have a triangular pyramid. This is a special one because then all the faces are triangles. Here you have a 1, 2, 3, 4, 5, so pentagonal pyramid, and so on and so on. So you have some kind of base, which is a polygon, so a figure, a two-dimensional figure with all straight line sides. Okay, it can be many sides. It can be 5, 6, 7, and so on. And all other faces are triangles that goes to one apex. Right. So here also we have a special one. This is not a pyramid because it has a curved surface. But it's very, very similar to the property of a pyramid because we have a certain base, in this case a circular one, and then we have another face that looks a little bit like a triangle almost. If you open it up, maybe it looks like this, a sector. So it's not really a triangle, of course, but it goes also to a certain point here, the apex. So we put it under here because it's very, very similar. And this is called a cone. The other family of three-dimensional figures has curved surface for sure, because this is a sphere, we call it. Okay, And today we will focus on the surface area of a sphere, and the formula for it will be surface area of the whole sphere. So imagine like a basketball or something like that, will be 4 times pi times radius squared. So we are going to try and use this. All right, so imagine if you have this basketball. I know there are actually different dimensions of basketball, but let's say we take the one with diameter 24 centimeter. Because the diameter is 24, then the radius is of course half of it, so 12 centimeter. And then if we want to know how much material is needed to make this basketball, so we need the surface area of the basketball. Then if we follow the formula, we will have 4 times pi times radius, in this case 12, squared. So if you do it in your calculator, just enter it in one go, so you don't have to worry about the order of operation. Clearly, we have to do this first, 12 squared, and then multiplied by pi by 4, okay? But if you enter everything in your calculator in one go, then you don't have to worry about that. So this is how you apply the formula. You can do that yourself, so I will leave it up to you to find the answer. In the next one, this is called a hemisphere, because it's only half of a sphere. So let's say something like this surfing ball. Then if you are asked to find the surface area of this hemisphere, clearly it's only half of a sphere. And because it's hollow, then we only need to worry about this surface area of this curved part here. And we know for sure it's half of a sphere, so we can say 4 times pi times radius, in this case 9 squared, and because it's only half of it, in the end we have to divide by 2, okay? So of course you can simplify the 4 and the 2, so you will have 2 pi r squared instead, but you can also just enter everything in one go in your calculator, okay? So remember, a hemisphere, then 4 pi r squared, like a formula of a sphere or surface area, but then you have to divide it by 2 because it's only half of a sphere. In the next one, say I have exactly the same thing, however, this is a solid one, meaning it is actually closed. So on this side here, it is actually a circle, so you need extra material for it. Do you see that? So you will have a hemisphere, which is a half of a sphere, but then you will also need material for this circle here, which is the cover of this hemisphere in this case. So don't forget, if you're asked to find the surface area of this one, so you will need to find the surface area of this hemisphere. So that will be 4 pi r squared divided by 2, the same as the one that you just did just now, okay? That's the hemisphere part. However, then you have to remember, I need also materials for the circle here. And because the circle will have exactly the same radius as the hemisphere, yeah, so this is the length, radius of the hemisphere, and this is radius of the circle will be exactly the same. I need only to add on. Formula of a circle is pi r squared, so this is what I will have. So I will have this hemisphere part, but I should not forget to add on the circle as well. Okay, so try that today. Your focus today will be everything about surface area of a sphere. Try the exercises and good luck!